increased meltwater collects in large lakes at high altitudes and poses a flooding risk to downstream villages. Landsat data is essential to monitor the growth of these lakes. Because of their location, glaciers are not easy to study in person, but Landsat's view from space allows us to study glaciers all around the globe. Landsat 9's improvements will make it easier to see features on the glacier surface. With that, we can better track how fast the glacier is moving. Knowing the velocity of the ice now and how it has changed over the past decades helps us forecast likely contributions to rising sea levels in a changing climate. Landsat 9 joins Landsat 8 to continue the unbroken string of Landsat data. For 5 decades, we have relied on Landsat's high-caliber, science-quality observations to understand and protect our home planet. And while Landsat 9 begins sending back data, we are already planning for the next evolution in the Landsat program.
Now that we've seen what Landsat 9 will do, let's take a closer look at the spacecraft itself. Landsat 9 is 15 feet tall, 10 feet deep, and 10 feet long. Once in orbit, it will deploy a 32-foot-long solar panel and 4-foot-long Earth shield. With fuel, it weighs almost 7,200 pounds. The satellite has 2 main instruments, Operational Land Imager 2 for reflective band data and Thermal Infrared Sensor 2 for thermal infrared bands. It will capture 700 photos each day and travel nearly 17,000 miles per hour. All right, we have a very special guest joining us who you may recognize from the movie Kong, Skull Island. Actor Mark Evan Jackson, thank you so much for joining us, also known as Landsat Steve.
In that film, I was known as Landsat
yes,
Steve.
And you have the jacket on, too.
I do. I have a bona fide screen-used prop, screen-used piece of wardrobe.
Love it. So in the movie, you played a Landsat researcher surveying a fictional Skull Island. Vandenberg looks spectacularly like that fictional Skull Island this morning. Yes. We might see Kong coming out of the distance.
We should all be very vigilant. Anything could happen.
So you actually got a chance to see the rocket up close yesterday. Tell us about that.
It's stunning. I mean, it's legitimately breathtaking and a really special opportunity to think about being so close to something that, you know, within a day is going to be headed for space, and within the fairing, something that's going to live on for, you know, many years, gathering data as an Earth observation satellite. The full culmination of what it means, you know, to be at this stage of the game ready to launch is so remarkable. The science and the engineering and the creativity and the curiosity and the ambition and collaboration that leads to this day is, I mean, it's legitimately inspiring.
How much did you know, if anything, about Landsat before you played the character Landsat Steve, and how does that compare to what you know about the program now?
I'm embarrassed to admit that I was completely unaware of Landsat as an entity prior to getting this role in the film, but immediately began looking into what it meant to be Landsat and to be a Landsat scientist. And Hollywood does a very good job of doing their research. Some of our hand props I've shown to some actual Landsat scientists, and they are very bewildered to go, like, a lot of this is right. Like, a lot of this is accurate. Now I'm fascinated by the goings-on at Landsat. Like, it's so remarkable to think about the nearly 50 years of continuous observation and data gathering, and also that all of Landsat's data is available and free to the public and to industry, and people are able to access it and use it to see how our planet is sadly changing.
Of course. Now, you're going to be watching launch just feet from where we're sitting. Yes. Over here. Hopefully, this marine layer will clear out enough so that we're starting to see the launch pad. It's a little better than it was a couple hours ago. I
feel very good about it. Yeah, I think things are heading in a good direction.
All right. Well, Mark Evan Jackson, thank you so much for joining us. We hope you enjoyed the launch today.
Thank you very much.
All right, let's go over to Daryl and Mick now for a check of the launch weather forecast. Daryl?
All right, thank you, Marie, and good to see that Landsat Steve's doing much better. Since we last saw him on Kong Skull Island, he was getting flattened.
Yeah, he looks a lot better than he did in that final scene. So
sure does.
Glad to have him here today.
Yeah, he was Land Flat Steve after that movie, so now he's back to his normal self. Good to see. Great interview. Thanks for that. The weather briefing just happened. We just got some news that is great. Of course, the 90% go is still on. our launch weather officer, Addison Nichols, saying that essentially we are looking great, even though when you look outside, it doesn't look all that fantastic. Our progress bar showing that we are at the weather briefing, and we just had it. Take a look at the satellite. We can show you a couple things that are in play here. 2 weather features along the central coast. Right to the left, there's a upper level low that's squeezing. To the right, a monsoonal low. And so in between, we've got some calm winds and a thick marine layer. Those don't affect launch. So right at T0, we're 90% go. Very small concern for surface winds. And again, just a minor factor, Mick.
Yeah, absolutely, Daryl. These weather looks great here for us in Vandenberg today, so glad to see weather's cooperating with us.
Unfortunately, the 30th Space Launch Delta forecast deteriorates significantly tomorrow, which is the backup day, because as you can see in this loop, that cold front will play bigger tomorrow than it does today. And in fact, it's only a 40% go, because ground winds will be gusting up to 24 knots. You can see in the upper left-hand part of your screen that upper level low. It will drop down and winds will increase. And that will put us in a situation where we don't want to be, Mick.
Yeah, absolutely. Those winds would be bad for us for the launch vehicle design and launch liftoff and control of the vehicle. So let's hope we get off today.
So we hope that that will happen. And looking back out to the pad, you can see there's some fog. There's even some smoke from nearby fires, making a little bit of a haze, but we are go for launch. We'll send it back. Actually, we'll talk a little bit about LSP in a future segment, but for now, let's go back to Marie.
All right, thanks, guys. We are at L-minus 25 minutes, 46 seconds and counting until liftoff of the 9th Earth observation satellite. And as we mentioned, this program dates back almost half a century. Here's an animation we're about to show you of the timeline of the Landsat program, starting with Landsat 1. It launched back in 1972, and it takes us all the way through Landsat 9, of course, launching today. The hashed lines for Landsat 7 through 9 indicate the uncertain lifespan of the satellites. Landsat 6 failed to reach orbit after launch. Still, it's hard to overstate the value of the Landsat archive of the past 49 years. One more history lesson before our next guest. Take a look at a photo we have from 1971 inside the Launch Control Center at Kennedy Space Center. There it is over on the Florida coast. This was when Apollo 15 was preparing to launch. And the man on the far right is Dr. James Fletcher. He was the NASA administrator at the time. And as administrator, he would go on to predict that if there were one space-age development that would save the world, it would be Landsat.
50 years ago, the U.S. Geological Survey had an idea. Satellites orbiting Earth that could help us monitor our natural resources. Today, the Landsat program is jointly managed by NASA and the USGS, providing an unparalleled record of Earth's changing landscapes for the benefit of all. 50 years of satellites. 50 years of life-changing data. One legacy continued with Landsat 9.
We have a special guest standing by now with NASA Edge's Blair Allen just outside Mission Control. Blair?
Thanks so much, Marie. Joining us now is a very, very special guest, the first Native American to serve as the United States Secretary of the Interior and as in a cabinet-level post, Deb Haaland. Secretary Haaland, thanks so much for joining the show this morning.
I'm thrilled to be here. Thanks for having me.
When we think of Landsat, Landsat's shown us a lot of interesting things, how we're impacted by drought, hurricanes, even man-induced activities like urban development and deforestation. How does this kind of data help the average person?
Well, I'll tell you what, those of us in the Department of the Interior and the government-wide, we're making policies every day to make sure that we can keep our environment safe and clean for generations to come. And hard data like this helps us incredibly. But also, look, we have opportunities to see those changes over time. The Landsat's been in existence for the last 50 years. The technology gets better and better each time. And so this is such a rich form of data that we can use that will help people's everyday lives. They may not know that, but there's folks working behind the scenes every single day to make sure that people can have what they need moving into the future.
Well, it's interesting because I was going to segue right into how this impacts policy, but you jumped there right away. So in your experience so far, have you worked with lawmakers to sort of chart some policies that would actually be helpful in regards to climate change?
Absolutely. And of course, we're in the thick of the climate crisis right now. We see that every day. Drought, wildfires, hurricanes. Hurricane Ida that devastated parts of the South and went all the way up to New England. Images like the ones that Landsat 9 will bring back to us will help us tremendously to guide us in how we are approaching climate change, working to make sure that we can make the best decisions possible so that folks have water into the future, that we can grow our food into the future. These are all things that will affect the daily lives of every single American, and quite frankly, these are pictures from around the world, not just the United States. So it's going to help folks all over the world to make those decisions, and it's unmistakable, incredible, hard data that we can use every day.
Absolutely. Thank you so much, Secretary Holland, for being on the show. Back to you, Daryl.
We are now L minus 20 minutes and counting until launch, and we've been monitoring the launch teams with our headsets. We're plugged in, and Mick, you just got some good news.
Yeah, we did. We got to hear from the launch team that everything is go. They're back on schedule. Things are working well, and we are green for our 11-12 launch opportunity this morning. So that's exciting that we're getting ready to launch Landsat 9.
That's great news. We've got a little moisture on the camera, as you can see there. There's a little mist in the air. There's some fog, and there's a marine layer, but none of it is expected to stop this opportunity today. Mick, want to talk about the launch time at 11:12 a.m. Pacific time. That actually moved 1 minute. What was the reason for that?
Yeah, Daryl, we moved the 1 minute to 11:12 this morning in order to accommodate a COLA, or what we call a collision on launch assessment, for the C-Train. The C-Train is made up of two satellites, Calypso and CloudSat, that LSP launched back in 2006, and we want to make sure that when we launch Landsat 9 this morning, we get it in that near-polar sun-synchronous orbit, but we don't want to hit our fellow satellites that are Earth-observing. So to avoid that, we made sure that Landsat 9 needed where to go. We moved the launch by 1 minute in order to avoid the CloudSat satellite.
Got to have room in space to get to space, and so we are looking good from that aspect as well. As we look at a shot here from the pad, you can see the steam that's coming off the rocket. Those are just vent valves, right, that are venting off excess liquid oxygen.
Yes, Daryl. Actually, as the team is finished up, we're in what we call topping mode. And as the liquid hydrogen boils off, that's what you see coming off there. And as we get ready to go into T-4 and counting, you will see those vent valves close, and that will stop and bring us to flight pressures.
Now, as you look at that rocket, there's actually a special dedication on it. You can't see it, but we're going to show it to you in a second. There's a special dedication there, and the reason is it's because of this man, Thomas Heater II. Heater began his 45-year career in the launch business at General Dynamics and relocated here to Vandenberg as a flight test engineer in the mid-'60s. He rose to director of Vandenberg launch operations, and during that time supported 200 Atlas, Titan, and Athena launches. Heater II passed away several years ago, and so ULA put this special dedication to him on the side of the Atlas V rocket, and you can see it there in memory of our colleague and friend, Tom Heater II. His family and friends gathered around the rocket as well and took a photo. And Mick, you had the privilege of working under Heater II, and may I just point out, between the U and the A, right there on the L, is Thomas Heater II's son, the third.
Yes, Daryl. Mr. Heater was a remarkable leader, humble person, and you know what? I had the privilege of working with him on many Atlas missions here at Vandenberg Space Force Base before I started with NASA. Mr. Heater was the director of launch operations at Space Launch Complex 3, but what I remember the most is he would always keep an eye on things going on at the pad, but he always took care of his people and looked out for things. And as you said, special note for us in Launch Services Program, we get to work with his son, who is today's launch director, who we will hear from later, and he's a remarkable person also. Well, great dedication to the Heater family.
Indeed, and we'll hear him report out as the last in the L-7 poll. We'll get to that in a bit. But first, I want to talk about LSP and their ability to bring together the rocket and the spacecraft.
Since the dawn of humanity, we have looked to the stars and dreamed of bridging the gap between the Earth and the cosmos. In the 20th century, NASA turned that dream into a reality by launching humanity into a bold era of scientific discovery. As pioneers of space travel, our best and brightest designed and built everything from the ground up, from launch pads to rockets, all of which were government-owned and operated. As NASA's science and robotics evolved, we encouraged a competitive launch market to develop, ushering in a new way to explore and discover through commercial spaceflight. Spacecraft customers from around the world, all with the same desire, reached out to find an expert at NASA for support. Thus, NASA's Launch Services Program was born. Our mission is to centralize NASA's launch services and address state-of-the-art customer needs when placing their spacecraft in orbit around the Earth, the Sun, or destinations deeper into the solar system. The LSP family is made up of a diverse tapestry of government and contractor engineers, analysts, operation experts, and business advisors, all united by a common goal: to get your spacecraft off the ground on time, on budget, and successfully to its final destination, wherever that may be. We match scientific and robotic spacecraft with the appropriate rocket and certify rocket performance and reliability. We support full-service missions, advisory services, and one-of-a-kind contracts. The Launch Services Program is the common thread that bridges the spacecraft organization to the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through launch. Whatever the vision or requirements, our team will be there, guiding our customers every step of the way on their journey through space. We are the common thread that connects the science world to the physical world by putting the necessary instruments in place. The thread that weaves NASA's industry-leading knowledge and support into the fabric of the commercial space market. We unite customers, capabilities, and culture to explore space through unparalleled launch services. NASA's Launch Services Program. We are Earth's bridge to space.
It is L-14 minutes and counting until liftoff. We've talked a lot about the history of Landsat, but we would be remiss if we did not point out the mother of Landsat, the woman who created and fought for it. Virginia Norwood was an MIT graduate and physicist working at Hughes Aircraft Company in the 1960s, and she knew NASA wanted a way to capture multispectral images from space. She set out to solve the problem, and through years of research, development, and testing, she created the multispectral scanner system that flew on the very first Landsat satellite. As a testament to her legacy, there is an entire group of women on Twitter who call themselves the Ladies of Landsat. They draw inspiration from Norwood as they highlight the work of underrepresented researchers, and we will hear from the co-founder of this group a little later after launch. Virginia Norwood could not be with us today, but we do have some of the Ladies of Landsat here at Vandenberg to see the launch up close, and we hope they enjoy it. Joining me now is Dr. Thomas Zurbuchen, Associate Administrator for NASA's Mission Directorate. Thomas, thanks for being here. It's starting to clear up. We can actually see the pad now. Tell us, how does Landsat tie into the entire Science Directorate portfolio?
Marie, what an amazing day. I'm just so excited. And of course, this is the first of 11 launches in Earth science in the next 2-3 years. just from NASA alone. And in many ways, the way I think about Landsat, it's really the foundation, the contextual data in which we look at all the Earth science we do, the research that we're doing, looking at our amazing planet. Because of the nearly 50-year time, the way I think about it is almost like a painting. Our research is the paint, the Landsat is the canvas. So it really belongs together very deeply.
Absolutely. And Landsat obviously looks down on Earth, surveying the entire planet. Does anything we learn from Landsat help us turn outward to explore further into the solar system?
Absolutely. You know, the work that we're doing in all of NASA, of course, expands beyond Earth science. We have missions that will go to the Trojans, a planetary mission, the James Webb Space Telescope launching later this year, and we use the very same technology that we're using for these analysis of the cosmos of other planets, looking at our planet. So yes, we learn from there to here, but very much we learn from the Earth science instruments to look at how we explore other planets.
Sure. I want to also ask you about this huge treasure trove of data available for researchers. It's available to the public. First, we have a quick video to explain that.
Landsat archives its 9 millionth scene. Each scene is a satellite image from space, about 115 miles wide. Researchers and, well, just about anyone can download scenes from the Landsat archive managed by USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence. That's 50 years of scenes like these, helping scientists and researchers understand how our planet is changing over time.
So we just saw a video there about Landsat having archived 9 million images and counting. We're adding 700 every day to that. Until the earlier 2000s, this data was not free. People had to pay per scene. Now that's completely free. It's available to anyone who wants it. Why is that so significant?
It's absolutely essential to unleash the power of the data that we have. Of course, our partnership with USGS remains strong. They are our, if you want, translators of really the images to the application spaces in our world, whether it's agriculture, fisheries, and beyond. But by making the imagery public, what happens is that companies, non-for-profit or for-profit companies, can take those data and put their own data on top of it and actually add to the value of the Landsat data in ways that otherwise would not occur. So it's a huge stimulant on entrepreneurial thinking of the type that the U.S. is known for.
And beyond Landsat, we're looking forward to launch in 10 minutes or so. But real quickly, what else are you looking forward to this year for the Science Mission Directorate?
Wow, it's an amazing year. Frankly, there's hardly ever been one like this. Just 2-3 weeks from now, around mid-October, we're going to launch Lucy to the Trojans. They're out there at Jupiter distances, bodies of the solar system we've never observed. The James Webb Space Telescope and 2 missions, one looking at the Island universe in X-rays, and then the first collision experiment of a spacecraft with a near-Earth object.
All right, Dr. Thomas Zurbuchen, thank you so much for joining us. Enjoy the launch. And with that, let's send it over to Daryl and Mick to take us through these final minutes before liftoff. Guys?
All right, thank you, Marie, and welcome back into the Mission Director Center. We've been listening to the launch team and just got some great news from NASA launch manager Tim Dunn, who declared that Landsat 9 is now on internal power. That means things are looking really good.
Yeah, Tim Dunn completed his poll with the team, notified them that weather looks good, the range is good, spacecraft is on internal power, like you said, Daryl, and those are all good indications that we are go for launch at 11:12 this morning. So excited to hear about that. The next up, we will hear from United Launch Alliance launch conductor Scott Barney. He will perform at L-7, the ULA teams poll, where we will hear the team give their go, ready to enter terminal count. And as we mentioned earlier, Launch Director Tom Heater will give that final proceed to launch.
And, of course, a dedication going up on the rocket with his name on it. His son, as you mentioned, the launch director. We'll be listening for that poll, which is coming at L-7 minutes. If you look across the bottom of the screen, you can see we're at weather briefing. Coming up is polling, and we'll hit that at L-7 as we count down. 60 more seconds until that moment. As we look out at the rocket, we see that we've had a little bit of clearing. That doesn't affect the chance for launch. But, Mick, it's nice to see that there's a little more visibility, 4 miles visibility, which is exactly the distance between this rocket and our host desk where Marie is in the launch viewing area.
Yeah, I'm feeling a lot better seeing some of that fog clear off, that Marie will be able to actually see something from where she's located. With all the guests she has up there, that's exciting. Like we said, the weather is really cooperating with us this morning, and as this fog here in Vandenberg moves out, weather still remains go, and the United Space Force has assured us that we have a green all the way through launch.
And once they go green and once this thing launches, it will be the 2,000th launch from Vandenberg Space Force Base, as well as the 300th Atlas. Let's listen in now as they conduct that poll.
L-minus 7 minutes.
Status check to proceed with terminal count. Atlas systems. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems. Propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems. Airborne.
Go.
Ground. Go. Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
Com.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
ALC. Verified T0 is set for 1812 Zulu.
Verified.
1812 Zulu, that's UTC time, and we are go. And I got to tell you, it was nice to hear Tom Heater III give that go right there at the end.
Absolutely. I got goosebumps here, Daryl. Every time we get to this point in a launch, it is great to hear the team give their goes. And this is special for me, too, to dedicate this to Mr. Tom Heater II and hear Tom Heater give that proceed to launch. That is so, I can't even explain how I'm feeling right now. I'm so excited for Landsat 9 this morning. Looking forward to this launch.
His family and friends also here present to watch this with all of us. We are now counting down to the T-4 hold, where we're going to get those clocks synced up with the T clock and the L clock. This has kind of been a windy road to get to this point, though, Mick. This launch originally scheduled for September 16th. It moved to the 23rd. There were some issues with liquid nitrogen getting to the pad because of a COVID-19 induced issue with liquid oxygen back in Florida. So it created a shortage here. Moved past that. Also had a little issue with the spacecraft getting it up because of the winds. But Launch Services Program stuck with it, stayed the course, and got us to the launch day today.
Yeah, you know, I'm very proud of the team. NASA's Launch Services Program, our commercial partner, United Launch Alliance, the United States Space Force, they worked hard to get through this. It has been a windy road to get here, but you know, the team's dedicated. This is just part of the rocket business, and these guys have maintained their processes, followed through their procedures, and worked diligently to get us here today, Daryl. So I can't say enough about the teams that have continued to bring us here for Landsat's launch this morning.
As we approach the T-4 minutes, what do we expect to hear?
So we're going to hear them pick up the count.
On my mark, the time will be T-4 minutes and counting. 3, 2, 1, mark.
So we just heard now the L clock and the T clock will sync up. We are now entering terminal count. At T-3, we will hear the team secure topping and verify that everything's at flight levels. Around 2 minutes and 50 seconds, we will hear that the flight termination system will go to internal power, making sure that all the safety protocols are on the rocket as we launch this morning. And around 2 minutes, we'll hear that the Atlas and Centaur vehicle go internal on battery power, which means is a clear signal that we will be launching on time this morning. And then at 1 minute, we will hear the United States Space Force give us a range go or green thumbs up, and we will then proceed into our T0 mark for Landsat 9 this morning.
As you can see there, the rocket against a dreary backdrop with a marine layer and a little bit of fog. It's 93% humidity here along the central coast of California. It's about little less than 60 degrees in the temperature that's outside. None of that is a factor. Over the past few days, we've also seen some smoke from a nearby wildfire at Sequoia National Forest. There you're looking right down the side of the booster, the Atlas V booster, and seeing that condensation coming off that super chilled skin of the rocket.
Yeah, I love that shot, that rocket cam shot. That'll be a great shot as we lift off this morning. And as you said, seeing that super chilled tank as it filled with liquid oxygen and liquid hydrogen on the Centaur tanks this morning, we're just excited about this. And we just heard from the team that they're going to flight levels on the tanks, and so that's a good sign that we are getting ready to close those vent valves and move into what we call step 3 for flight pressures.
Once that rocket lights, that orange fire will certainly change the light and change the mood of many of the folks who are watching this. Certainly on TV, you're going to see all of that. We've got all the cameras focused in, all the angles on this rocket. You can see on the progress bar, we are go for launch. Our next point is liftoff.
Vehicle internal.
So we just heard the call, Daryl, for vehicle internal. That's a good sign. We're going to hear the last poll here to verify everything is go.
Centaur LH2.
Securing Centaur LO2.
There's where they're securing and shutting off the vent valves and they're securing the vehicle.
Launching 137.
FTS armed.
Flight termination system is armed. We are getting closer and closer to that T0 mark, Daryl.
And there's a big moment at T-minus 45 seconds. What do we hear there?
We're going to hear the launch conductor, Scott Barney, verify from the last minute that everybody's ready to go, and we get a green to go for launch.
It's been a lot of work to get to this point, a lot of preparation. Let's listen in.
There we just heard vent valves locked, and as you saw, Daryl, you pointed out earlier that steaming off the vehicle has now stopped. The vent valves are locked.
Rock, report range status.
The range is green.
That is a great sign to hear range is green, Daryl, that we are good to go. Coming up on that poll from launch conductor Scott Barney.
40.
Stable at step 3. Status check. Go Atlas. Go Centaur. Go Landsat 9.
And there it is, the word to launch Landsat 9.
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above the marine layer.
Now 55 seconds into flight. Vehicle is now completing the pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good. Body rates continuing to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
A critical moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall vehicle.
At 1 minute 50 seconds into flight, vehicle is now 10.7, 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour. Now just under 2 minutes remaining in the boost phase of flight. At 2 minutes, 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet, and see the plume from the RD-180.
And the reaction control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction control system on Centaur, they're prepping it.
RD-180 engine operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Flight. Approximately 1 minute remaining now until booster engine cutoff.
Our tracker shot getting a great...
And now 3 minutes, 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
Great shot as it goes out over the southern Pacific.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking
and we
down.
have good indication of payload fairing jettison.
And you should see the payload fairings. Sometimes they come around the side.
12 minutes, 11 seconds.
There you see
RL-10 performance continues to look good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick. Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do. Yeah, absolutely. A lot of work to go on. But beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there. And that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see liftoff from here at the gravel pit. Earlier, I had the opportunity to speak with NASA Administrator Bill Nelson about today's launch. Take a listen. NASA Administrator Bill Nelson, thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape. It helps farmers, scientists, understand and manage land resources, and all of that is needed to sustain human life. Such things as food and water and forest. And of course, Landsat's long-term record of our home planet allows us to track the changes and the impacts of climate change.
And President Biden's fiscal year 2022 budget requests $24.8 billion for NASA. That's a 6% increase from last year, and also the strongest budget NASA has ever had for science. How do you quantify the value of NASA's science missions?
it is a very strong budget request. The value is immense. And when you're talking about data like this, it's hard data that arms decision makers with the tools they need to make tough decisions about our future. It's exploration on other planets, helping to answer the age-old questions. How did we get there? Are we alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing to develop resources for sustainable aviation. That is less pollution in the air from aircraft, and it will keep industry in U.S. competitive and drive fuel efficiency that helps the environment.
Administrator Bill Nelson, thank you so much for your time.
Thanks a lot. Have a great day.
All right, there is a live view on your screen now of Landsat on its way into orbit. Turning now to one of the many practical applications of Landsat, the U.S. Department of Agriculture uses it to track annual yield of every crop grown in the United States. Disaster managers can see impacts from floods and other natural disasters. Resource managers can use the data to direct crop rotation and monitor water use. Take a look.
America has always been a fertile land. Grasslands and forests and farms, from sea to shining sea. The U.S. Department of Agriculture tracks how many acres and the annual yield for every crop produced. From the big ones like corn, wheat, soy, to regional crops like cotton, rice, citrus. They track every year using data from Landsat satellites and others, combined with data from surveys on the ground. Landsat satellites see detail at the human scale, about the size of a baseball diamond, and can image individual farm fields. The program started in 1997 with North Dakota as an experiment. Other states became interested, and the program grew. In 2008, Landsat data became free to use, and the USDA could afford to map 48 states. During the growing season, the data helps estimate crop yields, which helps farmers and traders set prices for the harvest. Thanks to Landsat's detailed view, the USDA tabulates stats crop by crop, county by county, and state by state. At the end of each year, the data set is released to the public, and it is a beautiful sight. The patchwork of corn in yellow and soybeans in green in the Midwest. The diversity of crops in California's Central Valley. The clusters of citrus in Florida and California and Texas. We can see changes in farming through the years. The easiest to see is crop rotation in the Midwest, cycling between corn and soybeans. In northern North Dakota, there is a shift from barley and wheat to soybeans and canola. And we see an increase in cotton fields, shown in red, in Texas and Oklahoma. Thanks to the free and open access to Landsat data, the U.S. Department of Agriculture is providing our farmers with accurate data and helping maintain our nation's food supply.
All right, we want to bring in a special guest now from Northrop Grumman, the company that actually built the Landsat 9 satellite. Frank DeMoro, you are the Vice President of Tactical Space Systems for Northrop Grumman. And I understand this was your first launch out here at Vandenberg. How was it?
It was really special to see that rocket lift off.
Yeah, well, I tell you, we got a little lucky. It's also my first one, so we shared that together. But the last couple of days, the marine layer has been so thick, it's been very hit or miss, our view from here to the launch pad 4 miles away. So we lucked out. I'm glad you got to see it lift off.
Yeah, it was a special time, special time.
So this is Landsat 9 is the 4th satellite that Northrop Grumman has built for NASA. Tell us about the process. What goes into building a Landsat satellite and integrating it with the instruments?
Yeah, well, of course, the satellite that we build, the platform part of it, is really there to carry these special instruments to do the work that Landsat 9 is going to do. And so we have a dedicated team of engineers in Gilbert, Arizona, where we actually designed and built the satellite, working closely with our NASA customer to make sure that the structures and the power and all the data transfer systems are all in place to be able to accommodate the instruments. And then once we put that all together and put the instruments on the spacecraft, it goes through a rigorous test process. So that when we deliver it here and it gets launched like you saw today, it's ready to go.
There are so many things, as you know, that have to go right for a rocket launch to happen. And certainly the workers that you described in Gilbert, Arizona are a big part of that. All of the meticulous work I'm sure they had to do to get to this point. Can you talk a little bit about that team, what it's been like working through the COVID pandemic and any impact that's had at all?
Well, it's a really special team, and they're so dedicated to this mission. The fact that this is our 4th Landsat mission, partnering with NASA all these years in this type of mission is really special. And the team understands that. And as they've worked through the past year and a half, they've just continued to work through the COVID period, being dedicated to this mission, knowing what it really means to NASA, what it really means to the nation to get this data down to the ground. So they've persevered, they've worked really hard, and I'm really so proud of them. Mainly, that's the main thing I'm most excited for today, is what the team gets to see.
Well, congratulations to you and the Northrop Grumman team.
Well, thank you very much. Appreciate it.
You're welcome. Thanks for being here. All right, we are now at launch plus 14 minutes, 37 seconds and counting. We expect Landsat 9 to reach orbit, its intended orbit, in just a few minutes, and here's some things to know about that. It will circle the Earth at an altitude of 438 miles. It will travel at 16,760 miles per hour, or 4.6 miles per second. Each orbit around the Earth will take 99 minutes, so Landsat 9 will complete 14 orbits per day. Landsat 9 will take more than 700 pictures of Earth every day. All right, and as I mentioned, we are approaching that orbit milestone, so let's get over to Daryl and Mick to take us through the next few minutes. Guys?
That's right, Marie. We are just seconds away from main engine cutoff. Centaur has been burning now for several minutes. It's really close. When this happens, we're going to be in an orbit that's a little bit higher. You just heard we're just about a minute out.
Yeah, so what's happening is we have this first burn, and we're trying to get a slightly lofted orbit this morning into that near-polar sun-synchronous orbit, Daryl, so that we can get Landsat 9 up there. What will happen is main engine cutoff will occur, and then we will coast for several minutes to get Landsat 9 into the orbit it needs to be, and then we will get spacecraft separation at L plus 1 hour and 20 minutes.
Hard to believe. We're just a few seconds away from main engine cutoff, but hard to believe this spacecraft and this rocket have gone almost completely around the planet. Currently coming up through eastern Africa, over Turkey. We're just seconds away. Let's listen in to the call for main engine cutoff.
And we have MECO, main engine cutoff. Body rates look good. The vehicle is now recovering from the shutdown transients.
And there you go, Daryl. We heard from United Launch Alliance commentator Patrick Moore, who's done a fantastic job since liftoff of filling us in on all the activities that have been going on, and we just got confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about 1 hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of bit, right? Because as you can see in the bottom of the screen, we have removed our progress bar with the milestones. and now have a new progress bar, which will show you the time to spacecraft separation, which you can currently see is set at 1 hour and 3 minutes. We'll be monitoring everything here, but once again, we'll send it back out to the hill with Marie.
All right, thanks, guys. Joining me now is Landsat 9 project scientist Jeff Masick. Jeff, thanks for being here. How was the launch?
It is incredibly exciting and successful, so, you know, everybody's happy.
How much work has gone into getting to this point?
Well, 6 years, plus the preparatory period, you know, plus working through COVID, so you know, it's the team. I'm really happy for the team, right? I mean, this is 1,000 people probably have been working on this mission from multiple contractors, the government, USGS, NASA, and under tough circumstances. And so I'm just thrilled that it went off.
Absolutely. I want to ask you more specifically about Landsat 9's two main instruments, the Operational Land Imager 2 and the Thermal Infrared Sensor 2. A little bit of a mouthful, but we have a quick video about those, and then I want to ask you about them.
Sure.
There are two instruments aboard Landsat 9. OLI-2 is all about light. Once in orbit, OLI-2 collects sunlight reflected off Earth's surface. The light passes through a set of filters to separate out 9 specific wavelength bands, in visible and infrared frequencies. Each band provides different pieces of information about what is down on the surface. The second instrument aboard Landsat 9, called TIRS 2, collects thermal infrared wavelengths, or temperature signatures emitted by the Earth itself.
So that was a really quick breakdown. If you're a lay person like me, you have to watch that several times to absorb the information. Can you help us understand how those two instruments take measurements and work together and then send it back to Earth?
Sure. So as the video said, we have two instruments. One is looks at the shorter wavelengths, and so it basically looks at light that comes from the sun and is reflected back off the Earth to the OLI-2 instrument. The other instrument, TIRS 2, looks at the longer wavelengths, which are sensitive to surface temperature. And basically by combining the data from all the different spectral bands, you can fingerprint materials on the Earth. So you can tell what's vegetation, what's soil, what type of soil, and that's really what the scientists use, the analysis that they do.
All right. And I also want to ask you specifically about the different kinds of light that Landsat collects. We have another quick video to explain that.
True color images are made by combining red, blue, and green light. Combined together, these visible bands of light make up all the colors in the rainbow, and all of Landsat's true color images. Landsat also captures light that we can't see. That type of light can reveal some incredible things when you look at a false color image, like the difference between types of plants, how healthy those plants are, healthy coral reefs, and even dead coral reefs, fire tracking, ocean pollution. The possibilities are nearly endless.
Okay, so in that clip we heard about visible light versus non-visible light. I didn't even know non-visible light was a thing. True color versus false color. Again, didn't know there was even such a term as false color. So why do those things matter when you're interpreting data?
Right, so we really only can see 3 channels of light with our eyes at once, and so we have 11 channels on Landsat that we can put into any of those red, green, or blue layers to actually inspect. So a false color image is simply one where we take one of the infrared wavelengths that we normally can't see with our eyes, and we turn it into a red, green, or blue channel on an image to look at. In fact, when people are actually analyzing their Landsat data, they may look at all 11 channels at once using something like an artificial intelligence algorithm on a computer. So actually looking at the image, while it's beautiful, isn't always necessary for getting the information out.
All right, Jeff Masick, Landsat 9 project scientist, thank you so much for joining us. We hope you enjoy the rest of your afternoon, and I think you maybe deserve some time off after getting through that launch.
Yeah, it was great.
Congratulations to you. All right, turning our attention now to Landsat's imaging of the largest tropical rainforest in the world. Of course, I'm talking about the Amazon. It's nearly as big as the continental United States. But every year, deforestation is shrinking the rainforest, and Landsat satellites have been documenting the changes since 1984, excuse me.
The Amazon is the largest tropical rainforest in the world. At over 6 million square kilometers, the Amazon basin and the tropical forests that it holds are about the same size as the entire continental United States, home to millions of people and tens of thousands of species. Landsat is NASA's longest running record of our changing planet. Data have been taken from Landsat satellites since 1972, and that allows us to go back in time over several very important decades. The Landsat archive is perfectly timed to capture many different waves of colonization across the Amazon.
It's very powerful in this sense because it's not just an image, it's actually a bunch of information. What happens with Landsat is that it have several bands which have specific information. So pixel by pixel, you have at least 7 pieces of information that can be combined in different ways to see different things. So if you are interested to see vegetation, there is one combination that you make that can give you more information about vegetation.
Landsat satellite data are the most important source we have about how much deforestation happens each year across the Amazon. 40 years ago, we see small-scale deforestation creating roads that look like fish bones into the forest. But by the middle of the Landsat record, we see large-scale commodity production taking hold. So today's deforestation across the Amazon frontier isn't a single family. It's tractors and bulldozers clearing large swaths of rainforest to make room for industrial-scale cattle ranching and crops. So far, the amount of area that's been deforested in the Brazilian Amazon alone is equivalent to the size of the state of California. Deforestation in the Amazon happens with fire. Today's deforestation looks like the large-scale clearing of swaths of rainforest using heavy machinery, and then the land is burned, and burned again, to remove all of the tropical trees and timber. If we think about the size of a soccer field, we think about deforestation in those same size categories. So deforestation in the early part of the Landsat record might have been numbered in a single soccer field. Today's deforestation happens in tens, if not hundreds, of soccer fields. The value of the Landsat archive is that we have a long-term memory of the changes that have occurred across the Amazon frontier. And the Mapbioma's record of land cover across the Amazon is an excellent example.
So Mapbiomas is a network formed by NGOs that works with science, universities, and startups in technology. Our mission is to map and monitor everything that is related to land cover, land use in Brazil, always with an historical perspective. Because back in 75, 0.5% of deforestation, less than 1%. In 88 was 5%. And now we are getting close to 20% of deforestation in the Amazon. You know, between 20 and 25%, what the science is saying that it's maybe the point of no return. And that's very fast, right? 40, 45 years to lose 20% of the Amazon. So we could precisely identify how many events of deforestation happen in Brazil, or what's the size, who is responsible, what is the piece of land that is there, if they have an authorization or not. And we find out that over 99% of all the deforestation that happened in Brazil in 2019, it was illegal. It's really kind of a striking information that make us to move and say, okay, we can't accept, we just simply can't accept that we live on a place where the illegality is actually the norm, right? So this is like the type of thing that we want to kind of use the remote sensing data to kind of shake in the decision-making process of the different agencies in the public and in the private sector to take better decisions for what we call the stewardship of the management of our natural resources, which are crucial for all reasons in Brazil. The advantage of Landsat, first, is free. That's absolutely crucial for us. Second is that there's no other sensor, not even with lower resolution or high resolution, that will have a history consistent over the time for 35 years of image available. So if you really want to have a long history of understanding of any process in the Earth, Landsat is where you should go.
Without Landsat, we would not have the record we have today about deforestation and changing agriculture across a vast and important biome.
All right, it is now L plus 27 minutes, 22 seconds and counting. Let's go now to NASA Edge's Franklin Fitzgerald with the Landsat 9 project manager. Franklin?
Dell Genstrom, who is the NASA project manager for Landsat 9. Dell, how are you doing today?
I'm doing fine, thank you.
Now, Landsat has been around for quite a long time. How long have you been associated with this project?
Well, let's see, I started working on Landsat 8 back in 2005, so I've been working on Landsat satellites for about 16 years, and now the Landsat 9 project began in 2015, so we've been working on this satellite we're about to launch for a little more than 6 years.
Now, there has been a Landsat satellite in orbit continuously since 1972. That's a heck of a long time. How do you plan to keep the streak alive with Landsat 9?
Well, we're launching Landsat 9 to replace Landsat 7, which is run out of its orbit station keeping fuel. And so that's the urgency to get Landsat 9 up there so we can replenish the architecture of 2 healthy satellites, Landsat 8 and Landsat 9. Now, the history of Landsat is very interesting and sometimes chaotic. As you said, the first satellite was launched back in 1972, but NASA and USGS haven't had a stable budget line item through much of that time until 2014. And so now they have the Sustainable Land Imaging Program where they can plan for the future and develop future satellites. So the history in the past of trying to maintain that continuity of having 2 healthy satellites on orbit has had many ups and twists and turns and ups and downs, and the agencies have been directed down multiple different paths. Landsat 6 was even a completely commercial enterprise. Other agencies have participated. And so one of the reasons that this country has been able to maintain 2 active Landsat satellites on orbit for much of the last several decades is because Landsat 5 and Landsat 7 have lasted so long. Landsat 5 operated for almost 30 years. Landsat 7 has been operating for more than 20 years. And our USGS partners have just done a stellar job of managing the on-orbit assets and keeping them going. And but now we get to launch Landsat 9 up there to work alongside Landsat 8 and have 2 healthy satellites again up there.
That sounds great. That is good news. Now, have there been any challenges to getting Landsat 9 in orbit?
Well, there's always challenges. Satellites, no matter what project you're working on, satellites are hard to build. They're always custom electronics and software and hardware and to do whatever mission you're trying to do. And so there's always technical challenges. And certainly in modern satellites, there's lots of bits and bytes flying all over and lots of electronics. And we've had our challenges with things like that, especially some bits and bytes and electronics. But I think clearly the biggest challenge for this project has been trying to bring this mission to launch in the middle of a pandemic. Developing a satellite is very interactive, lots of meetings and gatherings to work through designs and design trades and testing and requirements and work planning for the future, working through risks. And suddenly we all found ourselves in March 2020, you know, like many people, sitting at home in our pajamas, wondering how we're going to complete this project. And this team has just rallied to be just a stellar group of people able to pull this mission together and launch it in the middle of the pandemic. The agencies and organizations involved have done a great job of building up the tools for working online and remotely. Northrop Grumman kept their doors open to keep critical work going on in the satellite while still, you know, keeping people safe. And they also worked with us to be able to monitor test data separately or remotely. Our USGS partners expanded their ability to keep mission operations and ground system development going remotely. Our mission integration team that brings together the flight and the ground system put together new tools to enable testing all of this together. And still there were lots of challenges with this. This has been tough on the team. And there's a stress level. You feel it, I'm sure, as much as anybody, that there's a stress with this pandemic, and it's been hard on the team. But and we've lost some schedule because of it, and there are other costs and whatnot, and we're still working through some of that. But I think that was by far the biggest challenge because it's just gone on for so long. And I'm just so proud of this team bringing this mission to launch, even still here in the middle of this pandemic.
Yes, well, it's a blessing to have you here. It's great to see the launch go off without any problems. And again, thanks for being on the show with us today.
All right, thank you very much.
Del Genstrom, NASA Project Manager for Landsat 9. Back to you, Marie.
Thanks, Franklin. The images Landsat 9 will capture provide astonishing detail about gradual changes that add up over time. This Landsat will show us finer detail than ever before.
Landsat's entire job is to collect light. How intense that light is tells us about what's on the ground. You can think of intensity like shades of a different color. Landsat 9, the newest satellite to join the Landsat fleet, sees 16,384 shades. That's 4 times the depth of color of the previous Landsat, meaning we'll be able to see more detail in darker spots like coastal waters and dense forests.
Joining me now to talk about that is Dr. Pete Doucette of the U.S. Geological Survey. As we mentioned, the USGS is a partner with NASA in the Landsat program. Now, Pete, you just heard that video with me about 16,384 different shades. My kids like to color. Never seen a crayon box quite that big with that many shades. Obviously, this is much more advanced technology. Why is that level of detail, that number of shades, significant?
Well, quite simply, it allows us to see what the satellite is looking at greater granularities of shade. Obviously, the human vision system cannot detect that between that number of shades, but mathematical algorithms certainly can, and that's what we use our math algorithms to distinguish between subtle changes among landforms on the Earth, especially in vegetation and various kinds of soil. And so it has remarkable discrimination power to tell those subtle changes in those kinds of features.
I also want to ask you about how the Landsat satellites work together. Obviously, they overlap a little bit, and we have another quick video to explain that.
It will take Landsat 9 and its sister satellite, Landsat 8 days to image all of Earth's land and coastal areas. That means we get a complete picture of Earth every 8 days. In this case, 2 satellites are better than 1. Landsats 8 and 9 can work together to provide near real-time data about what's happening on the surface of our planet.
So Landsats 8 and now soon Landsat 9 will be doing the job surveying the planet 24/7. How long will these two be in orbit together? And then are there any plans yet for Landsat 10?
So great question. So Landsat 8 will continue in orbit until roughly the late 2020s, which at that point, Landsat Next, which is the follow-on mission to Landsat 9, right, is expected to replace it in orbit. And so Landsat 9 will, of course, continue into the 2030s is the expectation. And so together, as you saw in the video, these do provide a combined 8-day revisit, which is a minimal threshold to meet to monitor what we refer to as subseasonal to seasonal changes going on.
And I understand this was also your first launch at Vandenberg. So what was it like to see, or should I say feel, the launch?
It was a great opportunity for me to witness my first launch, and I really want to commend all the folks at USGS and NASA for their dedication and passion over 6 to 7 years now of unremitting effort to make this day a reality. So it's really a remarkable accomplishment, and it speaks well to the Sustainable Land Imaging Agreement that we do have with NASA, which is a long-term commitment, right, to continue doing these kinds of Earth observations well into the future. And I guess this is a great opportunity to kind of renew those marriage vows, in a manner of speaking, between NASA and USGS, and we even had a little bit of fireworks to go along with it.
Absolutely. Well, so glad you could be here to enjoy the launch. Congratulations to you and the USGS team, Dr. Pete Doucette. Thanks again for being here.
Thank you very much.
All right, we learned earlier about how Landsat documents deforestation in the tropical rainforest. Now to the coldest places on Earth. Time-lapse videos of glaciers and ice sheets, as seen from space, are giving scientists new insights into how our planet's frozen regions are also changing.
From an observational standpoint, we're at a sweet spot where we can see many different aspects of the changing ice cover. And so the problems are then moving toward understanding what we see changing. It is pretty clear that we're going to understand what the ice is doing. I think that observational glaciology in terms of remote sensing is a very data-rich field now compared to 1972 when you had a few images. So we are beginning to get a historical record of the speeds of glaciers. And so we can watch how rapidly that surface is lowering as things speed up, or where it's thickening, and where the surface is actually coming up, where ice is actually thickening on land. With this record, we can go in and look at the speeds of ice flow over decades and how it's been changing. The reaction I get from other people that study glaciers is that I watch these videos too fast. I like to see the fluid nature of the ice. It lets you see the ice on the land as sort of this very active participant in what's going on. One of the places that I like to look at in this particular video of Hubbard is if you look just to the upper left off the 5 kilometer scale bar, you can watch the edge of the glacier just spread across the river bed that's coming out of the glacier that's adjacent to it. And it just moves, trees, it moves all sorts of material every single year, just advancing. So this video that shows the Walsh Glacier on the top and the Logan Glacier on the bottom, these are huge glaciers. They're the order of 4 kilometers wide or so. What we see as we loop through it is that the flow in both of these sits there for years, and then it will undergo a pulse of faster motion and then sit there again. What strikes me about this image of the Malaspina is that you can really see its nature, which is that it's a large puddle of ice. You've got huge glaciers that are flowing down out of a really high mountain range. And these big glaciers reach the coastal plain, and the ice just spreads out in this big puddle, like you'd taken a bottle of syrup and just dumped it in the middle of a plate. The Malaspina is sort of that big pile of syrup. The other thing that you see is that the ice coming in will head either to the left or the right of center for a while, and it will string out those moraines so that they get bent into these loop shapes. And it wasn't until I saw this video that I felt like I had a good understanding of just what was producing these amazing loops in the moraines. In compiling this Landsat record from Landsat 1 in 1972 up through today, I've gone through year by year, and I've tried to pick out the latest melt season image I can. So the white snow of winter is gone, and you can see the detail and the flow stripes and the crevasses in the ice, and build annual mosaics that give us an image of all of the ice in Alaska and the Yukon. And when those are all lined up, all 48 of them are lined up and played as a movie, we can see the behavior of the ice over nearly half a century. Having such a long record allows us to discern long-term trends and separate them from the kind of behavior you might get with a couple warm or a couple cold years. To have a persistent observational capability that's been in place ever since the first Landsat was launched, it really gives us a much better view of this really rapidly changing part of our planet.
The first Landsat satellite launched in July 1972. It would be the start of the longest data record of Earth's landscapes from space.
From 438 miles above Earth's surface, the newest Landsat satellite will collect data so detailed it can detect both natural and human-caused changes to the landscape. But what really makes Landsat unique is the half-century of data, an unbroken chain of observations over 5 decades. Let's take a look at how we got here. 1966, the U.S. Geological Survey proposes a satellite to study Earth's land masses. But what would that look like? Over the next few years, USGS and NASA researched their options. 1970, NASA gets the green light to build an Earth Resources Technology satellite, an experiment to study and monitor our planet's land surface from space. Launched in '72, this was the first digital data of Earth, repeated at regular intervals with geometric fidelity to allow comparison between observations. This changed how we drew maps, tabulated agricultural production, and assessed damage after disasters. In 1975, NASA launched a second satellite similar to the first. Now they were collecting twice as much data. With Landsat 3 replacing the aging original in '78, focus shifted to the advanced technology planned for the '80s. The Thematic Mapper instrument, launched on Landsat 4 in 1982 and on its twin Landsat 5 in '84, was a major step forward. Collecting 7 different wavelengths, at better ground resolution, and with higher precision, this was the beating heart of the satellite and became the workhorse for a generation of scientists. For the first time, Landsat data had 3 visible bands, red, green, and blue, allowing natural color composite images. With the addition of shortwave infrared wavelengths, the data could better highlight flooded areas, mineral deposits, and burn scars from wildfires. The thermal bands were also upgraded, allowing individual farm fields to be tracked. The 6th Landsat was intended to be another big step forward, but it never reached orbit after launch in 1993. Plans immediately began for Landsat 7, which would carry an even more improved sensor. At the time, the Enhanced Thematic Mapper Plus was the most stable Earth observation instrument ever sent into orbit, and the calibration could be updated while in space. For the first time, we had an instrument robust enough to collect lots of data, and we had a plan to thoroughly record the entire globe. Landsat 7 was put to work mapping coral reefs, and even produced the first high-resolution natural color map of remote Antarctica. Improvements to the thermal bands on Landsat 7 allowed states and counties to gauge how much water was used by crops. This helps them manage water resources efficiently. An important milestone occurred in 2008 when the USGS made the data available to download for free. Users were able to get the data they needed and not just what they could afford. It really unlocked a ton of innovation and created about $2 billion a year in economic benefits. The modern era of Landsat observations began with the launch of Landsat 8 in 2013. Having a push-broom-style sensor on Landsat 8 was a big improvement over the older scanning sensor. The Landsat 8 ground system that USGS runs is capable of receiving a lot more data than before. We're downloading over 725 scenes each day. That just wasn't remotely possible until Landsat 8. The 2 European Sentinel-2 satellites were designed to mesh with Landsat so that users can treat data from all the satellites as if it came from one single source. Now we get observations every 2 or 3 days instead of every 2 weeks. 2021 is the launch of Landsat 9, the next step forward. It will collect the best data ever recorded by a Landsat satellite, while still integrating seamlessly with the extensive archive. Since the early 1970s, Landsat satellites have allowed us to better manage our resources. Landsat data has enabled countless innovations and will let us track the effects of climate change into the future.
Over the past 50 years, Landsat satellites eventually run out of power and need to be replaced by another, newer Landsat satellite. But NASA is currently working on a new technology to refuel dead satellites in order to extend their lifetime. Let's go back to Daryl and Mick with more on this exciting new mission. Daryl?
Yeah, that's right, Marie. The target satellite is called Landsat 7, and it has enough fuel to let it last the rest of the year. Beyond that, it's going to run out, and its orbit will begin to decay. And when that happens, Mick, it's impossible for it to continue the mission.
Yeah, you're exactly right. Satellites are designed for a limited life, a mission life, and Landsat 7 is coming to the end of its life as far as orbit-keeping fuel. So that is going to be an important thing for us to look at in the future, how we can maybe help these things.
Well, and that's why NASA is exploring some new technology called OSAM-1. It's a pretty cool spacecraft. It stands for On-Orbit Servicing, Assembly, and Manufacturing Mission. It's being built. It is designed by engineers at Goddard Space Flight Center, and it's pretty cool because it'll be the first time that we will see a robotic refueling in space.
Landsat 7 was launched in 1999 from Vandenberg Space Force Base. And since going into orbit, the satellite far exceeded its 5-year mission lifespan. But now it's running low on fuel. Instead of becoming yet another piece of space junk, Landsat 7 has a new mission. As the host satellite for an on-orbit refueling spacecraft called OSAM-1, which stands for On-Orbit Servicing Assembly and Manufacturing 1. Here's how it'll work. Landsat 7 will lower its orbit while waiting for OSAM-1 to launch. Once in space, OSAM-1 will autonomously rendezvous with Landsat 7. And when OSAM-1 gets close enough, the robotic arm will attach the gripper tool from off of its payload deck. With a shoulder, elbow, and a wrist, the robotic arm has a range of motion similar to a human arm, making it ideal for this complex and dexterous mission. OSAM-1 then catches Landsat 7 by the Marmon ring, which is how it attached to the rocket when it launched. Once ground operators nestle the satellite onto OSAM-1's 3 berthing posts, the autonomous pit stop in space begins. A cutting wheel removes the thermal blanket off the original fuel valve panel, which was never intended for a refueling. Ground operators will then use OSAM's advanced tool drive system to prepare the valves. The first will cut the lock wire that secures the valves. Then a removal tool will spin the cap off and stow it safely on the servicer. Now it's time to fill her up. The Hypergol refueling tool is connected by a hose to an onboard fuel tank. So when the nozzle is guided over the original fuel valve, more than 100 kilograms of hydrazine, similar to jet fuel, will be pumped into Landsat 7. The on-orbit refueling is expected to give Landsat 7 enough fuel to safely deorbit to make way for future science missions.
And that extra fuel will allow Landsat 7 to continue on and re-enter Earth's atmosphere, which is important, keeping space junk clear out. That'll send it back down into Earth's atmosphere where it will burn up. And then that, Mick, makes way for another spacecraft to then take its place in that orbit.
Absolutely, Daryl, and that'll be able to keep things going in the future. I just think that's some cool technology that NASA's working on, that we'll be able to do something in the future with that, not only refuel a spacecraft, but maybe even do some manufacturing in spacecraft. That would be really cool technology that we could use for future missions.
It certainly would, and of course Launch Services Program, whom you work for, is going to be finding a rocket for this spacecraft. What can you tell us about that?
Yeah, so OSAM-1 is on our current flight planning board manifest, and we're looking at around January 2025, and we are working through all the requirements right now. And as you said, we will broker up and match OSAM-1 with the right rocket that is needed so we can get it on its way to help out Landsat 7.
And you can see how important this is to the future development of and exploration of the moon and Mars. You got to have robots in order to build stuff.
Yeah, absolutely. As we look forward to send humans back to the moon and then Mars, right, robotic demonstration missions like this are crucial so that we can build things in space, repair things in space, do other type of things in space. So very excited to see this kind of technology being developed across the country. And then, of course, Launch Services Program launching, and it's on its way.
That's right, and you guys are on top of it. I want to talk a little bit about the mission. We are currently at L plus 52 minutes. Here's a look at the graphical animation of what Centaur is doing right now with Landsat at the front. You're looking, it's pointing down. You see the nozzle up. You see Landsat 9 at the other end. Of course, it's an animation, but it's real-time data. It's taking data from the telemetry to show its representation in space. And currently, there's a reason why it's positioned like that. Tell us.
Yeah, so that we can keep the fuel on board as we get ready towards the front of the Centaur, as we get ready to prep for Landsat 9's separation, and then moving on to our next part of our mission, which would be main engine start 2 for our CubeSat deployments later on in the mission timeline. So far we've heard from Patrick Moore as they continue to look at this data that everything looks great, and the Centaur and Landsat 7 are on their proper trajectory.
That's right, and so for now, though, we've got to focus on Landsat 9's separation from Centaur, and as you can see at the bottom of your screen, we're about 27 minutes away from that and continuing to count down in that direction. Landsat 9 is just one part of the larger Earth science mission here at NASA, and the woman leading it is NASA's Karen St. Germain. Our own NASA Edge's Mr. Fitzgerald, Franklin Fitzgerald, is there with her live. Take it away.
Yes, thanks, Daryl. I'm joined by Karen St. Germain, who is the director of NASA's Earth Science Division, as you've said. Karen, thanks for joining us this afternoon.
It's great to be here with you, Franklin.
Now, I understand you were on console during the launch. How were things from your point of view?
It is always an enormous thrill to be on console for a launch. And today was no different. It was a beautiful, smooth launch. But in addition to that thrill, when I'm sitting on console, I am representing the hundreds of engineers and scientists who not only got us to where we are today for a launch, but these are the folks who will activate the instrument and then take the data that the instrument collects and turn it into real actionable information. So it's not only a thrill, but it's humbling. It's an honor to be representing all of those folks on console today.
Now, speaking of data, let's talk about Landsat's longevity record. How do we use Landsat to understand the human impact on the environment over a long period of time?
Yeah, so Landsat data is unique in the world. This is the longest data set looking at land, and when we look at that at a time series of that data, we can see changes in agriculture patterns, in forests, in urban environments. We can even see changes in the coastlines. And many of these are impacted by climate change. So that record helps us understand not only that change is happening, but how fast and whether it's accelerating and what it means for humans.
Disaster mitigation is a huge topic of interest with wildfires ravaging California year after year, in 2020 being on record for the most named storms coming through. How does the data from Landsat help our government to respond to these disasters?
Landsat data is critical in every phase of a disaster. Prior to an event, Landsat data can help us understand the risks. So, for example, if we have a forested area where the forest is no longer healthy, that can indicate that vegetation is fuel for a fire and is ripe for a wildfire. That can help planners and responders prepare, and then while a fire is happening, we can see it from space with Landsat and our other systems, and then after a fire, we can see the burn scars, which are important because that can be the location of a landslide when precipitation does come later. So it's in all phases of a disaster that Landsat can help us prepare, mitigate, and respond, and recover.
That sounds great. Karen, thanks for being with us this afternoon.
Thank you. It was great to be with you.
All right. Marie, back to you.
All right, thank you, Franklin. If you're just joining us, we had a spectacular launch this morning in California. The marine layer cleared just enough for us to see lift off 4 miles behind us. And NASA's Landsat 9 Earth observation satellite lifted off here at Vandenberg Space Force Base atop an Atlas V rocket. That was at 11:12 a.m. Pacific time, and it reached orbit just minutes ago. And in about 27 minutes or so, we expect to hear confirmation of spacecraft separation as the satellite orbits 438 miles above the Earth's surface at nearly 17,000 miles per hour. That's a view from a little bit earlier today of liftoff. The satellite will capture 700 images per day, building on the last half century of Earth imaging data that has revolutionized humanity's ability to manage resources and respond to climate change. Landsat data is also being used to help resource managers find algae blooms in America's lakes. Here's a video to explain.
It's really an amazing little critter, and it's been around for over 3 billion years. In 2016, Utah Lake exploded and cyanobacteria blooms. The problem is that many cyanobacteria produce toxins.
You may have heard it called blue-green algae, but it's really a kind of bacteria taking in sunlight to drive photosynthesis and giving off oxygen.
It actually requires quite a bit of lab testing to know whether or not it's a harmful algal bloom. And what we're really worried about is people and pets ingesting that cyanobacteria.
Dr. Kate Fickus is a harmful algal bloom scientist at Utah State University. She helps the Utah Department of Environmental Quality track conditions in lakes and reservoirs.
So Utah is the second driest state of the nation. Most of our major lakes are actually man-made reservoirs. They're heavily used for recreation. They're heavily used for agriculture. And they're really important to the state as a resource.
In 2017, harmful algal blooms returned to Utah Lake. This time, officials used satellite data to identify troubled locations. But how can instruments up in space tell us about microscopic organisms in a lake down on Earth? By measuring their blue-green color. Landsat collects light in visible and infrared wavelengths. Cyanobacteria reflect more green light than plain water does, allowing Landsat to identify algal blooms.
From satellite, what we see is basically that primary pigment, which is chlorophyll A, but the color by itself could be misleading. A nice picture is not necessarily providing a set of quantitative data.
Algal blooms can look beautiful from space, but the numbers behind the images are the important part.
Each measurement is highly accurate, and it's very much corresponding to the number of photons that are leaving the body of water, which could be related to the biomass and the amount of phytoplankton.
Dr. Nima Pahlavan is working with NASA and the U.S. Geological Survey to make sure Landsat users have consistent, accurate, and ready-to-use data about lakes and rivers. Water is difficult to study from space because only a fraction of the sunlight is reflected back to the satellite. But engineering improvements on Landsat 8 have leveled up its ability to measure the small signals from water bodies. After Landsat collects the data, it gets beamed down to the USGS Eros Center, where it is archived. The raw numbers pass through checkpoints to align the geography, correct for sun strength, and then compensate for the effects of the atmosphere.
So you essentially removing those atmospheric scattering and absorption.
Let's break down what NEMA means here. To measure the amount of cyanobacteria, you need to know how much light reflected off the surface. But some of that light gets scattered by molecules in the atmosphere on the way to the satellite, lessening the signal received. And sometimes light that never made it to the surface gets scattered into the satellite, adding a false signal. Like removing the haze from a photograph. Atmospheric corrections leave you with a quantitative measurement of exactly how much light left the water, known as aquatic reflectance.
You want to look at the actual physical measurements to derive physically meaningful products from satellite data.
And that's the goal, to transform the raw materials into finished products so that end users don't have to build it themselves.
By providing aquatic reflectance products, you're majorly reducing the burden on satellite users.
Although it is still provisional, NEMA's aquatic reflectance data product is available for download from the USGS. Scientists like Kate Fickus convert the data product to maps showing the amount of chlorophyll A, helping local officials pinpoint where to test for toxins and warn residents.
I use Landsat and other remote sensing technology to help local health departments understand where there's a bloom, the magnitude of the bloom, and the size of the bloom.
The spatial detail is another benefit of using Landsat data. Each pixel is only a 30-meter square, the size of a baseball diamond. Yet it collects data across a broad area. In other words, there is a lot of data at a fairly high resolution.
With Landsat, we can get into some of the marinas that are popular fishing and swimming spots in order to inform local health departments about making public health decisions.
For the 2017 outbreak, that's exactly what happened. Satellite data gave an early warning to local officials in Utah. The extra week of warning saved hundreds of thousands of dollars in healthcare costs. Monitoring algal blooms from aquatic reflectance data is just one example of benefits from Landsat's data products. Wildfires, snow cover, vegetation health, temperature, and more are available for every spot on Earth. Landsat's highly calibrated data products, free to download and use, are making detailed Earth observation data more accessible to users and bringing a greater benefit to society.
One of the experts we just heard from in that video is Dr. Kate Fickus, and we are lucky enough to have her with us today. I've been so looking forward to this. Kate, thank you so much for joining us.
Thank you, Marie, for having me.
Besides being an expert on algal blooms in our country's lakes, you also are the co-founder of the Ladies of Landsat. We talked about that earlier in the show, paying homage to Virginia Norwood. But tell us, what exactly are the Ladies of Landsat?
Yeah, the Ladies of Landsat are a group that I started in 2018, and really the goal of Ladies of Landsat is to increase diversity, inclusion, and equity for women and other underrepresented scientists in the field of remote sensing Earth observation. So we do this through a bottom-up approach, calling for amplification and representation of those women and minority scientists, and then a top-down approach. So asking leaders who have the power to make some change in the status quo or the dynamics and leadership in the field of remote sensing to help us out, get more women involved in remote sensing in those higher up positions.
Why did you feel it was so important to start this group and to make it an official group on Twitter?
Yeah, I've been a remote sensing ecologist for about 10 years now, and I would travel the world, go to international conferences. I didn't see many other women. I kept asking the question, where are all the women in these remote sensing and Earth observation sciences? So I started the Twitter group, and then I found my dear friend and colleague Maureen Crowley, and we saw the same thing, and we needed a community to help support women, underrepresented scientists, find a place in this community. It's generally dominated by men, and that can feel lonely, scary. It can lead to a lot of women dropping out of science, and especially remote sensing. We didn't want that. We wanted a place to be inclusive and a community to support each other.
Well, as a mother of two daughters, I'm really excited about the work your group does and the example that you set for my kids. So thank you. I know you're also going to get to meet with Virginia Norwood a little bit later. She wasn't able to join us here on the show, but I want to ask you, what do you want to say to her?
I have so much to say to Virginia, but I think two things really stand out. The first is thank you. Virginia was able to walk so that Ladies of Landsat can really run nowadays, although she was running back in her time as well. But she provides an anchor to prove that Ladies of Landsat have been part of this Landsat program from the very beginning. It's just maybe taken about 50 years to really find our voice and show that we're here to stay and we have a lot of power. I think the second one is congratulations still 50 years later after she invented the MSS without the support system or a community to back her up of Ladies of Landsat. Back then she was a trailblazer and that's just phenomenal. I'm so impressed.
Me too. Yeah, when I read about her I was like, wow, she is literally a hero. What do you want to say to women, not just women, but underrepresented groups? I mean, that's your target audience who are looking for community, and how can they find you?
They can find Ladies of Landsat on Twitter, and I always say if you're a Lady of Landsat, you're in if you want to be a Lady of Landsat. So find us on Twitter, follow, like us, and you're in. If you need support, if you need help, we'll find somebody to help you. We're always there for you. We want to be a collaborative community and choose community over competition always.
All right, Dr. Kate Fickus, thank you so much for joining us. We have covered a lot today, but there's more. Landsat is even helping rescue an endangered species of bird in the western United States.
We took freely available Landsat imagery and we developed this range-wide model that covers a vast spatial extent and a really wide temporal window to develop these fine-scale maps of habitat suitability for endangered species in an environment that's changing all the time. So I'm a research biologist / project manager for the University of Idaho, and I work on this endangered ridgeways rail in the southwestern United States. It's a species that needs attention. It is an indicator species of marsh condition throughout the whole Colorado River system. I know they're a marsh bird. They're like the size of a chicken, but they're high up the food chain in these marshes. And so if rails are doing well, it's indicative of a healthy system. So if we can develop products that help us manage marshes for the rails, it's also going to help protect habitats for other species. And we are really focusing on, okay, how do we take effective tools and apply them in space and time to maximize their benefit to the species? So we paired this spatially extensive on-the-ground sampling data with really extensive satellite imagery to develop range-wide habitat suitability models that can inform management actions throughout the range of this species. We needed a product that was accessible, available, covered our area of interest, and our time frame of interest, and Landsat really fit that perfectly for us. And we built this tool that is accessible to managers, and they can view it, and it's updated annually, so they'll have up-to-date predictions of habitat suitability throughout the entire range of the species, so they can really focus in on the areas that need management, that don't need management, that perhaps need on-the-ground confirmation. It should be a powerful tool to more effectively and efficiently allocate limited resources to ideally one day get this species fully recovered.
We want to go over again to NASA Edge's Blair Allen. He is standing by with a special guest from the U.S. Space Force to tell us about a secondary payload on this mission. Blair?
Joining us now is Major Julius Williams of the United States Space Force. Major Williams, can you tell me a little bit about what your role is for the Space Force?
Yes, first, Blair, NASA Edge, thanks for having me. So myself, I'm the chief of the Mission Manifest Office. As part of the Launch Enterprise and Space Systems Command down at Los Angeles Air Force Base. We essentially survey all launch opportunities, whether it's DoD, civil, or commercial, to look for the extra performance that's on the launch vehicle to get other small satellites or larger satellites to space.
I'm glad you mentioned small satellites, because that's actually part of why we're here today. Landsat, the main mission, but now also this lesser-known mission launching microsatellites or CubeSats. Can you tell us about it?
Yeah, so the L9 EFS, that's the Landsat 9 ESPA flight system, was essentially a joint partnership between the former U.S. Air Force and then NASA Goddard, but now the Space Force since 2019. So the ESPA flight system team, part of NASA Goddard Space Flight Center, the U.S. Space Force, and the Parsons Corporation, was essentially a joint effort to take an ESPA Grande ring and and then actually build out a system that could fly up to 18 CubeSats, and we are flying 4 successfully.
That's awesome. Now, you talked about a very complicated process, but it's a very important one. How do you actually launch these CubeSats from the rocket?
Yeah, so there's various ways to do it. Depending on the rocket system that's flying at that particular time, we've had successful missions where we've flown it on the aft end of the aft bulkhead carrier. On this particular one, as I mentioned before, in a ESPA ring, we are actually taking dispensers like this one right here. This is a nanosat launch adapter system. And at the point of time of the launch, this door would actually be closed, of course. But when it gets time for the actual deployment, an electrical sequence and a lot of other different variables that will happen, so that way it actually opens up, and then the satellite at that point in time will dispense and deploy at this desired time.
You know, it's very exciting to look at this CubeSat technology. So I'm wondering, can you tell me How does this kind of innovation help the Space Force in the future?
A lot, because whether it's the Space Force for science and technology, R&D, prototype missions, and a lot of our critical operational capabilities that we need to get on orbit, a lot of satellites are going down from the larger, well-known systems down to small sats or CubeSats or ESPA-class size satellite vehicles. So being able to use the multi-manifesting capability, also known across the community as rideshare, gives us the ability at a cheaper cost to benefit to the taxpayers' dollars and everyone involved to essentially mount up dispensers like this, load them up with CubeSats, ranges from various sizes up to an ESPA size, and then get it on orbit. So that technology is going to be critical as we continue to build out some of our national security space launch missions.
And it kind of helps you develop it kind of a la carte, right? Because you can do it in a very small footprint.
Exactly, a very small footprint, and if it's the same form, fit, or function, we actually have the capability to switch out those satellites. If we need a critical capability that needs to get on orbit to meet whatever the requirement is at that point in time, then we can actually, down to L-4, depending on the mission at that point in time and the variables at play, we can actually swap out those satellites, especially with it being a CubeSat size.
I'll tell you what, we're very excited to have you on the show today and wish the best of luck to you, the Space Force, and the CubeSat program and the CubeSat launch.
Yes, and we're looking forward to it. So about 2 hours or close to an hour after the fact, 2 hours and 14 minutes, we'll deploy these sequences out there and look forward to seeing the capability that it's going to bring out to the rest of the world.
Go CubeSats, go Space Force. Thanks so much, Major Julius Williams of the U.S. Space Force. Back to you guys.
All right, thank you very much, Blair. And back inside the Mission Director Center, we are tracking Landsat 9 and Centaur, which have been coasting for this entire time for an hour and 13 minutes. And as you can see in your progress bar, we're just a few minutes away from the actual separation.
Yeah, very excited about this, getting ready to separate Landsat 9 and continuing the Landsat program. Excellent launch today, and I'm just waiting for that moment when we hear the confirmation of spacecraft separation.
It certainly was beautiful from our vantage point. We've got a lot of cameras here that were watching it, and it was an enjoyable launch to see. But, Mick, it's just the first of many launches as we're going through the end of this year. Let's take a look at a preview.
Since 1998, NASA's Launch Services Program, or LSP, has served as Earth's bridge to space. Based at NASA's Kennedy Space Center in Florida, the program matches scientific and robotic spacecraft with launch vehicles for some of America's most inspiring space missions. Our mission, to successfully place spacecraft in orbit around the Earth, the Sun, and destinations deeper into the solar system. We centralize NASA's launch services while addressing state-of-the-art customer needs. But LSP does more than pair spacecraft with the appropriate rocket. The diverse group of government and contractor engineers, analysts, and advisors certify rocket performance and reliability. The team provides long-term technical expertise and support to spacecraft customers from around the world. The team manages launches from multiple sites depending on customer and mission needs. Cape Canaveral Space Force Station in Florida, Vandenberg Space Force Base in California, Reagan Test Site at Kwajalein Atoll in the Republic of the Marshall Islands, and the Pacific Spaceport Complex in Kodiak, Alaska. Building off of past success, LSP forges ahead to support NASA's future. The program has 4 upcoming missions in 2021. Leading off LSP's slate is Landsat 9, launching from Vandenberg. A partnership between NASA and the U.S. Geological Survey, the mission will monitor and manage land resources to sustain human life. Next up, launching from Cape Canaveral Space Force Station, Lucy will be the first mission to study Jupiter's Trojan asteroids, which may be remnants of the primordial material that formed the outer planets of our solar system. It's then back to the West Coast for Double Asteroid Redirection Test, or DART, NASA's first planetary defense mission. That will be followed by Imaging X-ray Polarimetry Explorer, or IXPE, launching from Kennedy. IXPE will expand our understanding of X-ray production in objects such as neutron stars and black holes. Years of testing, determination, and dedication, working as one. NASA's Launch Services Program is Earth's bridge to space.
Well, there you saw a preview of some of the exciting moments that are coming up for LSP. And let's talk about the next one up. It's Lucy.
Yeah, Lucy, launching on the east coast of Florida. We're excited about Lucy, just as much as we are Landsat 9 today. But Lucy, planetary mission, going to study the Trojan asteroids out by Jupiter. That is so exciting. Some cool science that's going to be going on there. You and I just actually spent a few minutes with Dr. Z, hearing a little bit about that and his excitement too. We are so excited to get back to Florida. And then turn right around, come back here to Vandenberg to launch the DART mission, which I think is an awesome mission also, from an aspect that we are doing a technology demonstration for defense, that we're going to impact a satellite into an asteroid to see if we can change the course of an asteroid.
That one's impressive.
We are just doing some cool science. It's not just LSP that's excited about these launches, but NASA in general as an agency, and we're just hoping everybody out there is excited about these upcoming missions as we are.
And we have a link for you if you want to find out more about the Lucy mission, which is the one right around the corner on October 16th. You can see it there on the bottom of your screen. Just go to the web address, nasa.gov/Lucy. Again, we are targeting October 16th for that launch. Time now until separation. We're dealing with a little bit over 3 minutes until that moment happens. And so let's talk a little bit about that, Mick. How exactly does Centaur separate from Landsat 9?
That's actually a cool little thing that happens is when it's time to separate, Centaur will send a signal to a device that's up there as part of the Marmon clamp that will release the separation bolts. And this Marmon clamp that is tied around, as you saw earlier in the upstand video, tied around on the bottom of Landsat 9, it will release that clamp, and Landsat 9 will then be pushed away using some separation springs. Very little force that is needed to get Landsat 9 going on its way for separation. So very simple design, but took a long time to do. Our mechanical engineers have been following this as they mated Landsat 9 to this, the Marmon clamp, and it made sure everything was right from a tension and perspective, and you know, we're just looking forward for that set moment.
And we're watching now an animation that is tied to real-time data, so we'll see that moment. You know, it's interesting, you talk about springs, putting it in the final moment. It takes rocket engines to get it up there, right? It takes rocket engines to get it close into orbit, but it does its final move with springs.
Yeah, absolutely. You know, we need all that thrust and power to leave Mother Earth and get out of her gravitational pull. But once we're in space and orbit, it takes very little work to make things happen. As we have watched Centaur and Landsat 9 orbit in this coast phase, we've seen the reaction control system just maintain Centaur in its space. So we're doing good, and that's just how rocket science works.
Yep, just about 70 seconds away now as we're counting down until Landsat 9 separation from Centaur. Once this happens, though, Mick, there's still more mission to go. There's some CubeSats on board.
Yeah, absolutely. Landsat 9 is our primary mission today, and once we separate Landsat 9, Centaur will begin its maneuvers in chilling down again the RL-10 engine and getting ready to restart, or what we call main engine start 2, for a few second burn there. And then they will do a MECO, main engine cutoff again, and then we will do a third burn to get into the trajectory and orbit that we need to deploy the two CubeSats that are on board. And Daryl, you had mentioned earlier in the show, today is a first for us also on Atlas V with a 4-burn. We will do that 4th burn to dispose Centaur and not leave it in space as space junk.
A point of history for the Atlas system and Centaur. We're listening now to see.
And standing by for spacecraft separation shortly.
Let's listen in. We are expecting spacecraft separation at any moment.
And we have successful separation of the Landsat 9 observatory.
And there you go.
So excited for that. I mean, so happy to hear that. That is just exciting to see Landsat 9 on its way and continue that 50 years of data.
And there she goes. An impressive sight. It is an animation, but here at the Mission Director Center, there was some applause behind us for the people gathered here. It's a nice moment for them. It's a nice moment for you.
Yeah, absolutely. We applaud, but it wasn't a huge celebration yet. I mean, we're very happy Landsat 9's on its way, but as we were just talking about, the mission's not over yet. We still have CubeSats to deploy, and we want to follow this through for mission success for all of the payloads on board today. But that is a huge milestone to get Landsat 9 on our way.
And it's also interesting that Centaur has to be careful to, as it goes on to its orbit, to put out those CubeSats. It's got to be careful to avoid Landsat 9, right?
Yeah, absolutely. The maneuvers that will happen is we will wait for Landsat 9 to get a way, and Centaur will then coast for about 30 minutes, allowing Landsat to get in where it needs to be and out of the way. And then we will do MES 2, which, as I said, main engine start 2, allow to get everything going for the CubeSat separation.
Well, that wraps it up for us, Mick. We had launch here, a successful on-time launch at 11:12 a.m. Pacific time, 2:12 p.m. Eastern time from the central coast of California, an Atlas V rocket putting Landsat 9 into orbit in a successful separation an hour and 20 minutes later. That's all for us. We'll send it back to Marie out on the hill.
All right, thanks, guys. Joining us now to talk about achieving at least mission success so far. We're not done, as Mick said, but joining us now is NASA Senior Launch Manager Omar Baez. Omar, thanks so much for coming out here. We were just watching the screen together when we heard confirmation of spacecraft separation. So what's that feeling like? Are you breathing a sigh of relief?
Wonderful. It's a great thing to hear. That phone that's sitting on the desk here has the control room patched into it, and I can hear them congratulating each other. So things are doing really well for us, and it looks good for Landsat.
How did things? I'm sorry. Go ahead.
Go ahead. We things evolved really easily today. Worked some minor issues with instrumentation, and then we had a slow-acting liquid oxygen valve, but that's about it. Smooth, boring countdown, and got it off right on time. So we're elated, waiting for the spacecraft to acquire signal, which should be happening just about now. And then in another 6.5, 7 minutes, they should have the solar arrays deployed and be well on their way to getting a good spacecraft.
You mentioned a boring countdown. That's good news. That means you're not really working anything significant, but that really speaks to the work of the people of the Launch Services Program. Can you talk a little bit about those folks and just all the work that the team has put into getting to a successful launch, spacecraft, and now to spacecraft separation?
So yeah, the team has worked phenomenally on this mission, and it's been a long haul. We had some struggles starting out this month. This mission was supposed to go earlier in the month, and we had some issues getting liquid nitrogen levels up to where they should be, and some technical issues that we found after the wet dress rehearsal occurred. And so, this pad has not been used for the last 3.5 years since we did the InSight Mars mission from here. So there was some bugs to work out of the mechanical stuff that's been sitting out here in this beautiful salt environment that takes some exercise, and no matter how much maintenance you do on it, until you fully exercise the vehicle with the cryogens on board, you don't find everything. And the kind of stuff we found was stuff with the instrumentation and so forth that needed to be recalibrated and reset. So the team's worked phenomenally. I can't be more proud of them. It's the start of a lot of missions for us in a row coming up, so it's nice to be able to get used to that pace again coming out of the COVID environment here and actually working and being with people versus looking at them on a TV screen. So the team has done phenomenally, but I need them to keep on doing a phenomenal job for quite a few other missions.
Everybody's got to get back on the other coast for Lucy next month, and then coming back out here to Vandenberg for DART. So you guys have a lot on your schedule.
That's correct. We're doing Lucy October 16th. So as soon as we get back, we do a wet dress rehearsal for them. The DART mission, the spacecraft just got here today. In fact, they were held at the gate because we were launching
Gotta wait for
Landsat 9, and so that spacecraft was delayed for a couple of hours until we launched. But it's now on its way to its processing facility here, and we'll attempt to launch that on November 23rd. And then we have the XP mission back at the Cape, which we'll attempt to launch December 9th of this year. And then we'll start the new year with GOES-T on February 16th. So we have quite a few missions coming up.
All right, NASA Senior Launch Manager Omar Baez, thank you so much for joining us. Congratulations on all the milestones so far. I know you still have to get through CubeSat deployment and a few other things, so we'll be keeping an eye on that. But good luck to you on the rest of the milestones.
Okay, thank you, Marie, and thanks for the public affairs team for making this all happen and being able to speak to our citizens about the great stuff we're doing here. Thank you.
Thank you. All right, to those of you at home, thank you so much for joining us for the Landsat 9 launch. We're going to wrap up our television coverage for now, but you can keep following live mission updates online at nasa.gov. Have a wonderful day, and now here's a final look, a replay of this morning's beautiful liftoff.